Hello students, and welcome back to another algebra video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, we are asked to describe the slope of the line. And what they mean by that, of course, is the line is falling. It's getting smaller as we move from left to right. So when we describe it, we say the slope is negative because the line falls from left to right. So the slope is negative because it falls from left to right. Okay, now find the slope. We remember that slope, and we call slope m, of course, is equal to the difference of my y-coordinates divided by the difference of my x-coordinates. So let's make this point number 1 and this point number 2. That gives us x1, y1, and x2 and y2. So our slope is y2 minus, minus y1 over x2 minus x1. Okay, 1 minus 3 is -2. And remember, minus a negative makes a positive, so 1 plus 4 is 5. And our slope, you can write it as -2 over 5. You can also write it as -2/5. It doesn't matter if the negative is on the top. It doesn't matter if the negative is on the bottom. It doesn't matter if the negative is out in front. However you want to write it. Okay, that was a nice review of yesterday. Let's go ahead and move on to what we have for today. Today we're continuing our work in section 3.5. We're going to talk more about slope-intercept form. That's that y equals mx plus b that we mentioned in section 3.2. So our learning target is that you know what linear equations in slope-intercept form are. What do they look like? How do they act? And our success criteria is that you can graph linear equations in slope-intercept form. So, know what they are and graph them. That is our focus for today. So, in order to know what slope-intercept form is, let's look at the definition. A linear equation written in the form y equals mx plus b. This is what slope-intercept form is. Y equals mx plus b. So, in slope-intercept form, the m is slope, just like yesterday, how we said m is y2 minus y1 over x2 minus x1. We were talking about the slope is m. In slope-intercept form, m is still the slope. And b is the y-intercept. Now you see why it's called slope-intercept form. Slope-intercept form, because inside of this form I have slope and an intercept. Slope-intercept form. Okay, so for example, they give us the graph of a line here, and we see that the equation is y equals x plus 2. Remember, anytime you see an x, there is an imaginary 1 in front of it. 1x is the same thing as x. So we know that the slope is 1 and the y-intercept is 2. If that was kind of confusing, don't worry, we're going to see more of that in today's video. So let's go ahead and move on. Let's take a little bit closer of a look at this slope-intercept form. So m is the slope and b is the y-intercept. We briefly mentioned that in the last slide that we looked at. Make sure that this is in your notes. It is super important that you understand that m is the slope and b is the y-intercept. M is the slope, not mx, just m is the slope. So if m is negative, right, if m is a negative number, then our line is going to fall from left to right. And if our slope is a positive number, the graph will rise from left to right. And whatever b is, that's where we cross the y-axis, because that's what a y-intercept is. It's where the graph crosses the y-axis. So the nice thing about slope-intercept form is we already have one of the intercepts. Remember in section 3.4, we had to find both of the intercepts so that we could draw the points and connect them with a line. Today, when we graph, we're given one of the points to start with, because that's what the y-intercept is. One more thing to mention is this little bit down at the bottom. It says a linear equation written in the form y equals 0x plus b. Remember, 0 times x is just a 0, so we can also write this y equals b. We call that a constant function. And remember, the graph of a constant function is a horizontal line. So notice when it says 0x, the 0 is the slope, because the m, or the number in front of x, is our slope. So if we have a slope of 0, we have a horizontal line. So anytime you have y equals b, y equals some number, we know that that's going to be a horizontal line that has a slope of 0. So this is actually written in slope-intercept form. Our slope is just 0. Okay, let's go ahead and move on to our first example, identifying slopes and y-intercepts. The problem asks us to find the slope and the y-intercept of the graph of each linear equation. So, in this example, all they want us to do is say, what is the slope? What is the y-intercept? That's all. And the reason we're doing this example is because we're going to use this information in our next example. So it's very important that you understand this example that we're doing right now. So remember that in slope-intercept form, when we have y equals mx plus b, we know that m is the slope. M is the slope, and b is the y-intercept. So if we look at part A, y equals 3x minus 4, what's the slope? Well, the slope is m, or the number in front of x. So in part A, 3 is the number in front of x. If we take y equals mx plus b, we can see that m is 3. So the slope is 3. There you go. Okay, Now the y-intercept is b. Y equals mx plus b. B is our y-intercept, and if we look at our equation, we can see that that is negative 4. 3x minus 4. So negative 4 is our y-intercept. And that's it. We're done with part A. With part A, we're done, because all it asked us to do was find the slope and the y-intercept of the linear equation. Okay, next, let's look at part B. We want y equals mx plus b. And we see, so let's look at the slope first. Slope is m. But wait a minute. This doesn't have an x in it. It's just y equals 6.5. Remember, that's the constant function that we talked about in the last slide. Y equals b, or y equals a number. And with constant functions, we have a slope of 0. So because there is no x in part B, our slope is 0. And our y-intercept is whatever y is equal to. Our y-intercept is equal to 6.5. Because if we graphed this, if we graphed y equals 6.5, we would go to the y-axis, 1, 2, 3, 4, 5, 6.5, and we would draw a horizontal line through 6.5. So of course the y-intercept is going to be 6.5, because every y-coordinate along this line is 6.5. Y equals 6.5, so the y-intercept is going to be 6.5. Okay, lastly, let's move on to part C. Okay, so y equals mx plus b, and the slope is m, so, oh, wait a minute. Part C doesn't look like y equals mx plus b. It's all out of order. I have negative 5x minus y. Whoa, whoa, whoa. We need to fix this. We need to change this equation so that it looks like y equals mx plus b. So I need to solve for y. This is kind of like the literal equations. Well, this is actually. This is what we did with literal equations at the end of chapter 1 in section 1.5. I have two variables in this equation. I have x and I have y, and I just want to solve for y. So we need to get y by itself. Okay. In order to get y by itself, I need to move this negative 5x over to the other side of the equal sign. So let's add 5x to both sides of my equation. It goes away over here, and I'm left with negative y equals 5x minus 2. Okay, now we're really close to looking like y equals mx plus b, but we have negative y. I don't want negative y, I want positive y equals mx plus b. So I need to divide by negative 1, right? Negative y is the same thing as negative 1 times y. So let's divide by negative 1 to get rid of the negative. And I have y equals 5 divided by negative 1. 5 divided by negative 1 is negative 5x. And negative 2 divided by negative 1. Negative 2 divided by negative 1. Oh, is positive 2. Okay. Hey, look at that. Now I have positive y equals negative 5x plus 2. And that looks like y equals mx plus b. So, what is my slope? My slope is m. It is the number in front of x. So my slope is negative 5. Careful, your slope is not negative 5x. I see some students do that sometimes. The slope is not negative 5x. It's just 5. Or excuse me, negative 5. Negative 5 is our slope. All right, and now our y-intercept is what? 2. Negative 5x plus 2. So 2 is our y-intercept, and we are done. Oh, and we put a box around the second one too. And there you go. Once you put your equation in the form y equals mx plus b, all you need to do is pick out m for your slope and pick out b for your y-intercept. And you're done. Let's check and make sure that we were right. Slope is 3, y-intercept is negative 4. Slope is 0, y-intercept is 6.5. They also solved, and they got that the slope is negative 5 and the y-intercept is 2. Perfect. Awesome. We were right. Okay. Let's go ahead and move on to our last example for today. Using slope-intercept form to graph. Okay, so now, instead of just finding what is the slope, what is the y-intercept, instead of just doing that, they want us to put the line, put this equation on the graph. So, we already know 2 ways of doing this, right? We can make a table of our inputs and our outputs and get those points and put them on the graph. We did that in section 3.3. We can put it in standard form, like this is in standard form. So we can find our intercepts and connect the dots that way. Now, we're going to learn a simple way, a nice, easy way to graph lines when they're in slope-intercept form. So you're going to have multiple tools in your tool belt. We can graph in standard form, and now we're going to be able to graph in slope-intercept form. So the first thing I need to do is I need y equals mx plus b. This equation, 2x plus y equals 2, does not look like y equals mx plus b. So I need to solve for y. That's the first thing I need to do, is solve for y. So if I'm trying to get y by itself, I need to get rid of the 2x. And to get rid of the 2x, I need to move it over to the other side of the equation. So we're going to subtract 2x on both sides, and it goes away on this side. We're left with y equals negative 2x plus 2. Now, some of you might have said y equals 2 minus 2x, but remember, we want y equals mx plus b. I want x to come first and b to come second. So we're going to write negative 2x plus 2, because now this is in the form y equals mx plus b. Okay, awesome. That is step number 1 done. Step number 2. What is my slope and y-intercept? Well, my slope is m, which is negative 2. Negative 2. And my y-intercept is b, which is 2. Okay. And there you go. That's step 2 done. Now, what we're going to do is now we're going to start the graph piece of it. We needed this information. We needed to know the slope and the y-intercept in order to graph. And now that we have this information, we can make our graph. So, if the y-intercept is 2, that means that my graph crosses the y-axis at 2. And you know what? I'm going to go ahead and make this purple so that you can see this is the y-intercept. And the y-intercept is the point where my graph crosses the y-axis. So, I'm going to put a point at my y-intercept. And that is step number 3. Okay, now, next step is I'm going to use my slope. Now, remember that slope is equal to rise over run. And this is super helpful because this tells us where is my other point going to go, right? I need 2 points to make a line. So where does this other point go? Does it go up here? Does it go over here? Like, where does this other point go? I need 2 points to make my line. So, if we look at the slope, and I'm going to erase this so I have more space. My slope is -2. So, what is my rise and what is my run? Well, it's kind of tricky to see here. Sometimes we have slopes that are fractions, and it's very easy to see. Oh, rise is 2, run is 3. If I just have a number like -2, is that the rise? Or is it the run? I don't know. So, here's what you can do. Anytime you have a slope that is a normal number, -2, 5, something like that, think of it this way. -2 divided by 1 is -2. So anytime you have a whole number, like 5, you can put it over 1. 5 over 1, that's the same thing as 5. And now, look what that does. My rise is -2, my run is 1. And remember, if this is a fraction, if we have like 4/7 or something, we already know my rise is 4, my run is 7. So this, putting a 1 underneath it, is only if you have a whole number as your slope. Okay, so now my rise is -2 and my run is 1. So what we're going to do is we're going to go back to our graph and we're going to take the y-intercept point that we had before. Now I'm going to start here and I am going to rise -2. Now remember, when you think rise, you're thinking up and down. You're thinking y-axis. So if I am rising -2, it means I'm going to go down 2. So I'm going to start at my y-intercept and I'm going to go down 2 boxes on the graph, down 2 numbers. Then I am going to run 1. Now if the run is positive, I'm moving to the right. I'm going to the right 1. If this run were negative, then I'd be moving to the left. So because this is positive, I'm going to go to the right 1. And now I've done my rise. I went down 2. I went over 1. So now that's where I'm going to put my second point. And this is how I will connect the dots to make my line. So let me do that again, just in case it went a little too fast. Let me do that again. we took our slope, -2, and we broke it down into its pieces, right? Slope is equal to rise over run. So because our slope was -2, we needed to find what is the rise, what is the run. We took -2 over 1, because that's the same thing as -2. And we had, oh, our rise is -2, our run is 1. If I am rising -2, I'm going down 2. And if I am running 1, I'm going to the right 1. So I put a point right at the end of my rising and running, and I connected the dots. Come on, give me a straight line here. There we go. More or less. All right. So that is our graph. The last thing it wanted us to do was identify the x-intercept, because in slope-intercept form, we know what the y-intercept is. But what is the x-intercept? We don't know just from looking at the equation, but if I look at the graph, I can see where it crosses the x-axis. It crosses the x-axis at 1. This point is 1, 0, which means my x-intercept is 1. Ta-da! And remember, another way we can check and make sure that we're right is our slope is negative. So we should be falling from left to right. The graph should be falling. And look, it is. Our line is pointing down if we look from left to right. Okay, awesome. Let's check and make sure that we were right. Rewrite the equation in slope-intercept form. Find the slope and the y-intercept. Plot 2, rise -2, and run 1. And draw another point. Connect the dots. X-intercept is 1. Boom! Awesome. We were right. Okay. That is all I have for you today. Thus concludes section 3.5. So yeah, rate yourself on a scale of 1 to 3. How are you feeling about today's learning target and success criteria? Do you understand slope-intercept form? Are you getting there, or are you still like totally confused? How are you doing? Okay, and if you have any questions, be sure to reach out to me, your teacher, a friend, something like that. All right, here are some practice problems that you can do to practice the skills that you learned in this video. The first set of problems are like example 3, and the next set of problems are like example 4. All right, and as always, let's end our video with a launch. Today's launch comes from Robin Williams, and he says, "No matter what people tell you, words and ideas can change the world." Words and ideas can change the world. So there's 2 different things that this quote makes me think about. The first is your words matter. Your words can change the world. So don't think that you can just say whatever you want and it's fine. Pay very close attention to the words you are using. Are your words uplifting and encouraging to other people? Or are your words mean and disrespectful? Like, pay attention to the words that you say. The other thing that this makes me think about is ideas can change the world. What ideas do you have that could change your world? Or your friends, a friend's world or something like that. And what ideas are there that could change your world that you don't even know exist? An idea, like some of the launches that we do. Maybe these are ideas that could change your world. They could change the way that you think about the world. So, Pay close attention to your words because they can change the world. And be open to new ideas that could change your world and the way that you live in the world. Okay, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.